Hello everyone. My name is Muhammad Haikal bin Cik with matrix number 160060, and today I will be presenting my final year project for Pixel 2025. The project title is Internet of Things IoT based smart shoe system for rehabilitation monitoring by using cloud computing, and my supervisor is Dr. Azman Abdul Malik. Now, let's begin with by explaining the background of my project. Currently in rehabilitation center, patient progress is mostly monitored manually by therapists. This manual process can take times and can sometimes lead to incomplete or inaccurate data record. To overcome these issues, this project proposed an IoT-based smart shoe system, and this system is use smart sensor embedded inside shoes insole to track foot pressures and walking motion during rehabilitation session. And all the data collected is sent in real time to the cloud environment, which is in this project we will use Amazon Web Services. And this will ensure that the data is stored safely and can be accessible by therapists anytime and from anywhere. And lastly, a web-based dashboard is developed to display all the data live, so the therapist can monitor the patient's condition directly from the system. Next, I would like to explain how the system works in general. So basically, this system is a wearable IoT device that embed in a shoe insole to monitor foot pressures and motion for rehabilitation monitoring. And it uses two main sensor, which is force sensitive resistor FSR, and also MPU 6050 accelerometers to detect foot pressures and also to capture motion and balance information. And then all the collected data is transmitted in real time via Wi-Fi using an ESP32 microcontroller, and all the data will be sent to the cloud environment by using MQTT protocol. And then once the data reach the cloud, it will be handled by several AWS services such as IoT Core, DynamoDB, and then the data will be presented on a web-based dashboard. This dashboard will allow physiotherapists to remotely monitor the patient working patterns and rehabilitation progress efficiently in real time. Okay, next is about proposed solution and objective. For these projects, it contains three problem statement, which is the first one is rehabilitation progress is still monitored manually by therapists, which is time consuming and can lead to inaccurate or missed data. The second one is lack of IoT-based real-time data collection using smart shoes with foot pressures and motion sensor. And the third one is collected data is not stored securely or can be easily accessible for therapists to review it remotely. So to overcome these issues, a proper cloud-based system is needed. And there are also three main objectives. The first one is to develop a smart shoes IoT device that capable of capturing real-time foot pressures and motion data for rehabilitation monitoring. The second one is to integrate AWS cloud services for secure real-time data storage and remote accessibility. And the third one is to implement a web-based dashboard for real-time monitoring and assisting therapists in evaluating patient rehabilitation progress. So there are three proposed solution, which is the first one to implementing IoT device module. The second one is to implementing cloud module, and the third one is to implementing dashboard monitoring module. Okay, now let's go to the next part, which is details of the proposed system. As I mentioned before, there are three main module in this project. The first one is IoT device module, and the second one is a cloud module, and the third one is a monitoring dashboard module. For IoT device module, they are consist of two sub-module, which is sensor and also control board. The force sensor and also the MPU 6050 accelerometer will be used in this project, and for the control board, we will use ESP32. And for the second module is a cloud module, which is consists of three sub module, which is data ingestion, storage sub module, and also hosting sub module. And the third one is monitoring dashboard module, which is this module is used to display all the real time foot pressures and motion data, and it will allow therapists to review life status and patient records via a web based dashboard. So this is the overall system architecture diagram for this project. As you can see here, there are three main module, which is IoT device module, AWS cloud module, and also dashboard monitoring module. And to be more specific, in IoT device module, they are consists of two microcontroller, which is ESP32A for the left side, and also ESP32B for the right side. And for each size, it will have three force sensor and one accelerometer. And all the devices will be connected to the Wi-Fi and will be transmitted to the cloud environment by using MQTT protocol. And secondly is the cloud module. For this part, there are several AWS services that being used. And the first one is AWS IoT Core, which is used to collect all the data from IoT devices. Then the second one is AWS Lambda, which is used to enhance the data. And the third one is Amazon DynamoDB, which is this is a cloud-based databases that offered by AWS. And the last one is AWS EC2 instance, which is these services will be used to hosting the web application dashboard monitoring data. And there are also underlying services, which is AWS IAM, that are being used to give policies for all the services and allow them to communicate with each others. And the third one is the dashboard monitoring module, which is this module, the web being hosted on AWS EC2, and all the data from cloud environment will be fetched securely by using AWS API Gateway. And this project will bring several impactful benefits to the rehabilitation fields. Firstly, it will improve rehabilitation monitoring. By using real-time sensor data, the therapist can now track patients' walking patterns, foot pressures, and balance much more accurately and consistently compared to the traditional manual observation method. And the second one, it will helps to reduce manual effort, which is the therapist no longer needs to relies on visual check or manual notes during session. The system will automatically record and update patient data, which will save times and minimize human errors. And thirdly, it offers a remote accessibility since all the data is transmitted to the cloud and will be visualized on a web dashboard. Physiotherapists can monitor a patient progress from anywhere without needing to be physically present. This makes it convenient for both therapist and patient, especially in outpatient or home care scenario. And lastly, the scalability and cloud-based. The use of AWS cloud services will ensure the system can handle large amount of data securely, and it's flexible enough to support additional patients, sensors, or features in the future without major change to the infrastructure. Now let's move on to the entrepreneurship potential of this project. Firstly, this project can be expanded into a commercial smart rehabilitation kit. This means packaging the smart shoes device together with cloud services and selling it to the physiotherapist clinics, rehabilitation center, and private hospital. It can help them to modernize their rehabilitation monitoring process using IoT technologies. The second one, I see a potential in offering a subscription-based cloud monitoring services. In this model, clinics can subscribe to access a real-time data dashboard and reports through the cloud system. This provides continuous remote monitoring for therapies and making patient management more efficient and convenient. And lastly, the project can be scaled beyond just smart shoes. The same system structure can be expanded to other medical IoT solutions. For example, a device for elderly fall detection, posture correction wearables, or even heart rate monitoring. This allows for business growth into other healthcare markets while reusing the existing IoT cloud infrastructure. So, these are the future entrepreneurship opportunities I foresee based on this system. Okay, now let's begin with project demonstration. For the first one, this is a demonstration on IoT device module. As you can see here right now, I am already wearing the shoes, and both devices ESP32A and also ESP32B already turned on and successfully connected to the Wi-Fi. So now let's move to cloud module, which is for this project we are using Amazon Web Services cloud, and there are several services being used. And the first one is AWS IoT Core, which is these services is used to collect all the data both from ESP32A and also ESP32B. And right here, as you can see right now, both data from ESP32A and also ESP32B has been successfully transmitted to the cloud by using MQTT protocol. And the next one is Amazon DynamoDB, which is this is a cloud-based databases. And right here, I'm already created several tables, and all the data both from IoT devices and web application dashboard monitoring will be stored here in DynamoDB. And the third one, this is a EC2 instance where the web application being hosted. And now let's take a look on dashboard monitoring. First of all, the doctor needs to make a registration first. For example, so the doctor has been successfully registered. And now let's try to log in. So here, this is a dashboard monitoring. First of all, the doctor needs to create a new patient and fill in the form. For example, so the patient data has been successfully created, and so this is a main dashboard of the patient. To start record the data, the doctor first of all need to click on the start monitoring, and then as you can see here, there are several sections here, and right now this is the data value that has been successfully displayed on the web dashboard monitoring. And this is a graph that shows the pressures and also the food balance for both devices is ESP32A and B. And there are also live statistic for both sides, and they will show a pressures analysis and also balance analysis for the exercise. So to download the data, the doctor need to click on the stop button and click on download sensor data. And the data will be stored in CSV file. So this is data from the patient. And the doctor also can delete the patient information.